Hello and welcome to episode 17 of Lex Out Loud, World Building for Science Fiction. I'm your host, Lex Starwalker. I'm working on my third novel, my first science fiction novel, and I'm taking you along with me for the ride. In season 1, I've been exploring world building in depth. Today, I'm going to do my best to continue to answer some of the questions you've submitted about the setting. So we started these off last episode in episode 16 and answered a few listener questions in that episode, and just going to continue on today. So rounding out our world building discussion with your questions. So if you have a question about the setting, something you've been wondering that I haven't explained or haven't mentioned, feel free to let me know. You can fire that off in our Discord if you'd like, and I can try to address that question in a future episode. So our first question today comes from Lord Garglemon, who asks, what does it take to build new space stations, and how many are there? So that's a great question, or a couple questions. So the first thing you need to build one of these space stations is lots and lots of titanium, or steel, or graphene, depending on which space station we're talking about and how far in the future we're talking. So yeah, primarily the early versions of these cylinders will be made of titanium. And, in the beginning, some of that titanium will probably come from Earth, but some will also come from the moon. And as we go forward, all of the materials to build these things will come from the moon and various asteroids. So yeah, we could also use steel. Titanium and steel are roughly equivalent as far as strength. However, titanium's a lot less dense. So a given amount of titanium will have less mass than steel. And so when we're talking about building things in space and we're having to either lift materials up from Earth into space to build with, or we're having to lift materials up from the moon and carry them over to Earth orbit to build with, mass is very important because we have to move that mass around. So the lighter we can make things, the better. So I think for that reason, titanium will be the material of choice. And there's loads of titanium on the moon, and there are some proposed methods that we could use to refine titanium from the materials on the moon. Now, to my knowledge, none of these methods have been tested, but presumably, hopefully, that will be some of the things that will be done in the upcoming Artemis missions as we build a surface base on the moon. I'm hoping that at some point they'll get to testing, refining titanium from materials on the moon. Other materials we could get from the moon include silica, which we can use to make glass and make solar panels, aluminum, iron, water, which includes hydrogen and oxygen, that can be used for propellant. And yeah, so lots of good stuff on the moon. So yeah, you'll need lots of titanium. And then later in the history, once we have the ability to mass produce pristine graphene, then production will shift to using that for these things once we can produce enough of it to use it in that way, because graphene is even lighter and stronger than titanium. And we can build these cylinders much, much bigger with graphene than we can with titanium. The other thing that you need is something to actually construct the cylinder or whatever kind of orbital or space station you're building. And these will probably be done by these huge robotic jig factories, which will be able to build the cylinder all in one piece. We'll fabricate it in space all in one piece. So it'll be a lot stronger. And these will be completely automated. There won't be humans putting pieces together. It will be robotic assemblers putting these things together. And yeah, so there's some exciting things happening in the world of 3D printing right now. I just recently read an article about a company that's developing these robotic 3D printers. Now, I've never actually used a 3D printer myself before, and I don't know a whole lot about how they work, and isn't something I've thought a whole lot about. But from reading this article, I guess that when you normally 3D print parts, so let's say you want to build something. So you're first going to 3D print all the individual pieces and then assemble them into whatever it is you want to build. Well, it sounds like when you 3D print these pieces, they're printed on support trees. If you've ever made a model before, you know how all the plastic pieces are all together in this like tree. It's like one plastic piece. And then you have to cut all the little pieces out of the little plastic tree and then file all the flashings off and stuff like that. Well, I guess it's a similar thing with 3D printing. And so what this company is developing is a robotic 3D printer that can not only print all those pieces, but then can remove them from those skeleton trees and assemble them. And I guess right now that's kind of the bottleneck in self-assembling or just fabricators, we can print all of these different parts, but it takes a human to take the parts out of the trees and assemble them. So once we can make these robotic 3D printers that can do everything, so much more will be possible than what we can do now. So there's at least one company that's working on this, and just some really exciting stuff just happening in the world today. I just saw a video last week about another company that's working on 3D printing tissues, and they hope to eventually be able to 3D print organs, replacement organs like kidneys for people. And this actually is being done on the space station, because in order to make these larger organic structures like a kidney, you have to do it in zero gravity. It was a really fascinating story about it, and it's too complicated to go into in detail now. But just to kind of put it in a nutshell, let's say you're trying to 3D print a kidney here on Earth. As you're laying down these different layers of cells, gravity, it tends to make the layers on top sink down into the layers below them, and you can't keep them separated. Or in order to keep them separated, you have to print structures to do so, and then those can limit what kind of tissues you can make, or they can interfere with the functioning of the tissues. However, if you can do this in zero gravity, then things stay exactly where you put them, and you don't have gravity pulling things around. So this particular company is working on this technology, and they have a 3D printer on the space station right now that 3D prints tissue. And so, yeah, that's really exciting stuff too. And while I'm thinking of these things, I just saw an article, I think it was last week, I posted it in our Patreon, about in Europe, they are building a vertical particle accelerator. So most of the particle accelerators we're familiar with are circular, and they're usually underground. But this one, instead of sending the particles around in a horizontal circle that's flat on the ground or under the ground, they're going to be able to send particles straight up and down to see the influence of gravity on things. And this, when it's completed, will be the tallest structure ever built by humans, and they're 3D printing it. Unfortunately, they're calling it a space elevator particle accelerator or something like that, which I say it's unfortunate because I think some people are confused and think it's an actual space elevator, and it's not. But really cool that they're making this particle accelerator, and I believe it's gravitons they're going to study with it. But we're going to learn more about how gravity affects these things, and also this will be a groundbreaking moment for just 3D printing technology, that they can do this. So yeah, I mean, I guess to answer the question to the best of my ability, what does it take to build these new stations? Yeah, it's going to take a lot of materials, whether that's titanium or graphene, and it'll take a lot of time and labor. But again, the lion's share of that labor is going to be done autonomously by robots. But of course, Humans are going to have to design the thing and program the fabricators that build it. So, it's not like the robots are going to do everything for us, because we have to tell them what to do and how to do it. But yeah, that's basically what's going to be required. And then Lord Gargamon asked, how many of these stations are there? So I'm glad that you asked, because this is something I've spent quite a bit of time on in my world building, is figuring out how many of these stations are there, how big are they, how many people are on them, where are they, what order are they built. And, most, maybe all of this may not ever appear in any of the books, but I feel it's really important information for me to know. I don't want to just come up with this city-sized cylinder out in space and just create it in a vacuum, pun intended, and just try to write a story about that. I want to know where that cylinder came from, and how did we get from, right now, 2021, to this future where we have this thing that people are living on, and what were the important steps along the way. I feel like those are things I need to know. So I've spent a lot of time working on that stuff. And because of that, I can answer this question. So let me pull out some of my documents here, and I will tell you how many of these space stations there are. All right. Now, although I have most of the world building done at this point, I shouldn't say I have most of the world building done. I have most of the world building done that I feel I need to have done to start the novel at this point. Although that is the case, this is all subject to change. Something I remember from my last book I wrote is, you can have all this world building done and feel like you're solid on everything. But then as soon as you start writing, you will often run into things that you didn't think about, or you suddenly realize something you were thinking isn't going to work for some reason. So there's just these other levels of detail, I guess, that you don't really think about until you actually start writing. And then suddenly you realize, oh, I need to research this, and this, because I don't understand enough about it to write about it. Or like I said, you realize that something that you planned before isn't going to work, and you have to go, fix things or change things. So this is all subject to change. So especially if you're listening to this podcast in the future and you've already read the book, what's in the book is the primary source. So if I say something right here that contradicts what you saw in the book, then I'd go by that, because, this is early draft kind of stuff. So, this stuff may change, but as of now, April 2021, this is what I'm thinking. Okay, so like I said, I wanted to start with today and then go forward. So, right now we do have I don't know if I'd call it a settlement, but we have a space station in orbit, the International Space Station, that has people on it and has had people on it continuously for, I think, around 20 years, something like that. So that's something that's going to continue. The last information I've seen is that there is a plan to deorbit the ISS in 2024, which at time of recording, that's only 3 years in the future. So from what I've seen, that's still the plan. And by deorbit, I mean that they'll get everything out of there that they want, and then they'll put it into a descending orbit. I'm not sure if that's the right term, but they'll maneuver it in such a way that it will burn up in the atmosphere, and if anything survives that, it'll end up in the ocean. So yeah, last I knew that was planned for 2024. I don't know if that's still the plan or if that will be changed, but as of now, the ISS will no longer be around in 2024. We also have the Lunar Gateway Station, which is soon going to be built in orbit of the moon. So that's in the very near future. That's going to happen. And then, so the third thing I have happening kind of in my timeline after the ISS and after the Gateway Station is a number of co-orbital facilities in low Earth orbit. So co-orbital means that there'll be a number of small space stations that are fairly close to one another in low Earth orbit in the same orbit. So if you were standing on one of these stations and looking at the other stations, although you're all orbiting around the Earth, you're all flying over the Earth at a pretty high speed, the other stations would appear to be stationary from your perspective to you. So these stations will be, I hesitate to use the word stationary, but with regards to one another, they won't move, but they'll all be orbiting as a group around the Earth. So these will be built up over time, one by one, and some of the various stations or functions that these stations would carry out would be we'd have a fuel depot, so a place to store rocket fuel and where rockets can refuel. And eventually that fuel will be coming from the moon instead of the surface of Earth. We'd have a variable gravity biological research facility. So one of these small stations will have at least a part of it that can be spun for gravity and will be able to be spun at different rates to give different levels of gravity, to be able to do biological research, to be able to research plants and animals and humans, to see, how things work in different gravities. So for instance, something we don't really know anything about right now is how will human conception work in microgravity or in low gravity. So I'm sure we would start out with other mammals first, perhaps mice. So they might test trying to fertilize mouse eggs and raise mouse embryos in microgravity and in, a third Earth gravity, a half Earth gravity, a full simulated Earth gravity. Because that's another thing. Will they, if we have one of these stations that can give 1G of artificial gravity, will they develop normally, or will the rotation influence something? So there's millions and millions of questions to be answered about how plants and animals and humans specifically will work or not in various gravities. So we'd have at least one facility to test those things, and also a pilot space solar power program. So I've talked a bit about space solar power on the show in the past. So just very simply, the idea is you put solar panels up in space where you have access to sunlight 24 hours a day, 365 days a year, and you make electricity from that sunlight, and then you can beam that using either microwaves or lasers, beam that electricity wherever you want it, whether it's to a space station in space or to a receiving station down on Earth. So one of the big drawbacks of solar power here on Earth is that the sun isn't shining on those solar panels all the time. First of all, it's not shining during the nighttime. And also if there's cloud cover and things like that, that can diminish the energy that you get as well. So if you could put your solar panel up in space, it can get sun all the time. So we'd have a small facility to work out all that so that we can later mass produce these space solar power satellites, because that's where most of our energy, at least for the inner solar system, is going to be coming from. So that'll be that's kind of the first thing that isn't a definite thing that's planned right now in my history is this suite of co-orbital facilities to just further research in microgravity and to start exploring constructing in microgravity and building things and stuff like that, as well as like these companies that are investigating products that you can make in microgravity that you can't make on Earth. Another one I just saw a thing about recently. I can't remember exactly what it's called, but it's a form of fiber optic cable that allows much higher bandwidth than the silica-based fiber optic cable that we make now, that can be made in microgravity. and would allow you to, for instance, the fiber optic cables that go across the oceans would need a lot less repeaters to boost the signal with this space fiber optic cable. I forget what it's called, like Z-FLAN or something like that. It starts with a Z. It's like an acronym, but yeah, and would have much higher bandwidth as well. And that is a product that this company that's looking into producing it can potentially sell it for enough profit, because it's such a value. It will be such a valuable product that it can actually be profitable for them to make the stuff, even though they have to make it in orbit, which of course makes it much more expensive to make. So that's really exciting for the future of space construction. Because that's really what we needed to get us going. Is we need some things that we can make in space and then sell on Earth that will actually be profitable, so that we can start to build this infrastructure in low Earth orbit, and also start to build our knowledge of how to do these things in low Earth orbit. So after our these co-orbital facilities are built in low Earth orbit, next we build a fuel depot at the Earth-Moon L1 Lagrange point, which is between Earth and the Moon. And next is the building of a lunar surface base. And this will be a place where we can do robotic mining of lunar resources and refining. And will only be crewed by a small crew that rotates out on a regular basis, because it will just have lunar gravity, because it will be on moon surface. So you can't have people staying there for long. So people will stay there maybe a few months and then rotate out. But for the most part, the mining and refining and all that will be automated, and people will be there just to oversee and fix problems and whatnot. About the same time, we'll see a growing number of space hotels cropping up in low Earth orbit. There's plans, I believe I shared this on the show on an earlier episode. I know I posted it in the Discord a while back, but there is a company planning to build a space hotel by 2027. So this is something we may be seeing very soon, but those will continue to grow in number and popularity. And then we will have a low Earth orbit manufacturing station. Oh, and these first space hotels that are built won't have artificial gravity. So, you won't be able to stay there for very long, but you can go for a weekend or a few days or whatever. But then they'll start building ones that have some artificial gravity, probably not a full 1G to start with. But then this manufacturing station in low Earth orbit will have rotating sections for the crew, so people can stay there longer. They're still probably not going to be at a full 1G, but even a little gravity is better than none, presumably. And this manufacturing station is going to start building solar or a space solar power satellites. After that, so we've already got a base on the moon. We'll build a second base on the moon, this one on the South Pole of the moon, for more mining and refining of lunar resources. And at this point, this is when things start to get really fun and interesting, because then we build a space elevator on the moon. So this is going to go from the surface of the moon to the Earth-Moon L1 point, which you remember we just put a fuel depot there not too long ago. So now we have a space elevator going to the L1 point. And at that point, that's when we'll start to be able to build these cylinders and whatnot, because we're getting resources from the moon. We can then lift those resources up to L1 using the space elevator, which will be much cheaper than using rockets. Even with the moon's much lower gravity than Earth, it still takes rocket fuel to get things from the surface of the moon up to L1. So once we have a space elevator, that'll be a lot easier and cheaper to do. And so at that point, it'll be pretty easy and cheap to get the materials that we've refined on the moon up to L1, and from there to whatever Earth orbit we want them at. So after the space elevator is built on the moon, a robotic jig factory is built in low Earth orbit, which I just talked about those a little bit ago. That's what we're going to make these huge habitats with. And then the first space station with artificial gravity is built in low Earth orbit. And this first one, it's very small and it's a torus, so it's donut shaped. This first one can only hold about 500 people, which is huge compared to anything we've built in space up to this point. But yeah, this is a small torus that's built. Let me see. I look on my other sheet here. I've got stats. It's 200 meters in diameter and has a population of, as I said, up to 500 people. All right, so this torus that's built in low Earth orbit, it's 200 meters in diameter. It does provide 1G of artificial gravity, so full Earth gravity. So this is quite a few firsts. This is the first space station built that provides full Earth gravity on the whole station. So before now, we had some stations that either had artificial gravity for just part of it. For instance, the manufacturing station has a part where the crew stay that rotates for artificial gravity, but the whole station doesn't have artificial gravity. So these earlier stations, either only parts of them had artificial gravity, not the whole station. They also didn't have a full 1G of artificial gravity, even in the parts that had gravity. It wasn't a full 1G because they were smaller. And these smaller stations, if you're going to spin it enough to have a full G of gravity, it would be spinning too fast for people. People would be getting sick on there. So these earlier stations tended not to have gravity on the whole station, and where they did have gravity, it was less than a full G of gravity. So this is the first station that has a full 1G of gravity over the entire station. Again, it's donut shaped. The whole thing spins. Now, because it is so small, it's only 200 meters in diameter. In order to get that 1G of artificial gravity, it's spinning at just under 3 RPM. So I had quite a bit of discussion in an earlier episode about research that's been done into rotation and what levels of rotation people can tolerate without getting sick and having problems. And 3 RPM is a level of rotation that people can get used to, but it's fast enough that there are probably going to be people that never get used to it, and there are going to be people that have a much harder time than others getting used to it. So it's definitely not a place where just anybody could go and be comfortable. Some people just would be sicker than a dog on this thing. So although it could have a population of up to 500 people, not just anybody can go up there because of the high RPM. So, it's going to be mostly astronauts and researchers that have been checked out that can handle that or that can acclimate to it. But it's a pretty big deal. Also, not only is it the first station with full 1G gravity on its entirety, but it's also the first station that's built by one of these robotic jig factories and that is fabricated in orbit. So, one of the reasons it can be so big is because of that. So you look at like the International Space Station and you look at the Gateway station that's going to be built around the moon. And those are very limited in how big they can be because every piece of that is lifted up to orbit on a rocket. So you can't make any part of it bigger diameter than your rocket or than the cargo fairing of your rocket or the payload fairing. So if your rocket is X meters in diameter, then that's the biggest thing you can put inside of it, right? So, you look at the International Space Station and it's a bunch of pieces stuck together. And no one of those pieces is very big in diameter. And that's why. So once we can build a robotic jig factory in orbit that can build these single piece structures in orbit, then we're no longer limited by the size of the rockets as to how big of structures we can build. All right. So this torus is the first space station that's kind of on the level of what I'm talking about for this book, where we have full Earth gravity on the whole thing, and it's a large station. And it is a low enough spin rate that, there are a lot of people that would be fine there once they got used to it. But again, not just anybody would be okay. They'd have to be checked out first to make sure they're not going to be miserable up there. So it's at this point, after this small torus is built in low Earth orbit, that the space elevator on Earth is built. After the space elevator is built on Earth, then the first cylinder habitat is built, and that is built at L1, the Earth Moon L1 point at the top of the Lunar space elevator. So now we've got a space elevator on the moon going out to L1. We've got a cylinder on top of that space elevator at L1, and we have a space elevator on Earth. So we can easily lift things up from the surface of Earth to Earth orbit, to Earth geostationary orbit. We can also easily lift things up from the surface of the moon to L1. And then it's very easy to lob things back and forth between those two space elevators. So now we have our system, our cislunar infrastructure established, where we can start building these large structures in space much more easily and much more quickly and much more cheaply. So this first cylinder that's built atop the lunar space elevator is 2 kilometers in diameter and has a population of up to 36,000. So a big jump from 200 meter torus to 2 kilometer or 2,000 meter cylinder, and from a population of 500 in the torus to a population of 36,000. And part of that is just because it's so much bigger, and part of that is because it's a cylinder instead of a torus, so you have a much larger livable area. All right, so to get back more directly to Lord Gargamon's question, which was how many of these cylinders are there? Well, how many space stations? So counting this first torus, so I'm just counting the big space stations that have full Earth gravity. I'm not counting all the little space stations that either don't have any gravity or have very low gravity or whatever, but these bigger structures. So the first one is the torus in low Earth orbit. The second one is our first cylinder, which is built on top of the lunar space elevator at L1. So then our third station like this, I'm just going to call them cylinders, even though, remember, the first one was actually a torus, not a cylinder. So this third cylinder is built either within or near a near-Earth asteroid. And this will be a cylinder that's the same size as the one at L1 at the top of the space elevator on the moon. So another one of these 2 kilometer diameter cylinders. So this one that's built at the near-Earth asteroid is going to facilitate mining that near-Earth asteroid for all kinds of stuff. We can get all kinds of metals, including precious metals like platinum and rare earth elements. So lots of really good, really valuable stuff, as well as tons of building materials will be gotten from asteroids. And a lot of people think that you got to go all the way to the asteroid belt for that, but that's actually not the case. There are actually numerous asteroids near Earth. So we'll go there first because it's much closer. So that would be the third cylinder. Again, the first one's really a torus, but the fourth one will be, again, the same size as the last two, 2 kilometer cylinder. This one is built either within or near a near Mars asteroid. So the one that's built at the near Earth asteroid will be mining and refining materials for building around the Earth and the moon. And then the one that's built near the near Mars asteroid will be mining and refining materials for building projects around Mars. So next up, the fifth such station that's built is a larger cylinder at L5. So this is another Lagrange point in the Earth-Moon system. And the cylinder at L5 is a bigger one. So they've been building these 2 kilometer diameter cylinders, and now they scale up And they build one about twice as big, a 4-kilometer diameter cylinder. So the 2-kilometer cylinders held up to 36,000 people. This one they build at L5 can hold up to 180,000 people. So that's like 5 times as many people. So that's the 5th one. The 6th station is a cylinder that they build on top of the space elevator that they build on Mars. So they build a space elevator on Mars. And just as I said, once we have a space elevator on Earth and the moon, it makes it really easy to get stuff from Earth to the moon and from moon to Earth and everywhere in between. Well, the same kind of thing when we have a space elevator on Mars, it then makes it very easy to send things back and forth between Earth and Mars. So they build a cylinder atop the Mars space elevator. This one's even bigger than the one they build at L5. So this one has a 6-kilometer diameter and a population of up to 380,000 people. Now, these cylinders are all still titanium. The 7th station is a cylinder built in the asteroid belt to facilitate mining asteroids from the asteroid belt. These materials will be used at Mars, probably somewhat, but more and more, I think the materials mined in the asteroid belt will be used for endeavors in the outer solar system. So the cylinder that's built at the asteroid belt is the same size as the one that was built at L5, with a 4-kilometer diameter and a population of up to 180,000 people. Station number 8 is built at L5, Earth Moon L5 again. So this is the second one they built at L5. And this is the biggest one yet. This one they scale up to an 8-kilometer diameter, holds 750,000 people. And this is about as big as you can make these things out of titanium. So this is kind of, they've reached the limit of what they can do with titanium, is a cylinder that can hold 750,000 people. And then the 9th one, number 9, lucky number 9, is where the story is going to be taking place. This is an even larger cylinder that is built on top of the Earth space elevator. And this is the first one built of graphene, and it has a diameter of 22 kilometers. So we went up from 8 kilometers to 22 and has a population of over 5 million people. So the way I'm thinking right now, the cylinder where the story takes place, which is the first city-sized, although I guess 750,000 people, I mean, that's probably a city. But the first like big city-sized cylinder, the first graphene cylinder, this is where the story takes place. It's the 9th of these structures built. It's built above geostationary orbit of the Earth, above the Earth space elevator. And yeah, it can hold, I think it's 5.6 some million people, but a lot of people. So yeah, right now I'm thinking that as of the story, there are 9 of these large space stations. 8 of them are cylinders. The first one's that little torus. And then the plan going forward is they will continue to build more of these in the what we call the L5 neighborhood. So there's already 2 cylinders there, and they're going to keep building more there as needed. And those will be connected to one another with cables, so you can use electric cable cars to travel from one cylinder to the other in this L5 neighborhood. Also, keep in mind that these Lagrange points also exist in the Mars system. So Mars actually has 2 moons, Phobos and Deimos. And so that, you remember us talking about the 3-body problem. We get into the 3-body problem there. So the Lagrange points of Mars will be a little more complex, but my understanding is Mars will have an L5 point. So when there's enough people living on the cylinder at Mars, and there's enough more people wanting to live near Mars, they can start an L5 neighborhood around in Mars, in the Mars system. And there's also L4, which is a similar Lagrange point to L5. So they could build cylinders at the Earth Moon L4 as well as the Mars L4. So there's lots of good places to build these things. So they'll just keep building more and more. But I do think they'll tend to add more cylinders to the L5 neighborhood as opposed to building one off all alone somewhere, unless, it's opening up a new part of the solar system for exploration and use of resources. But barring that, they'd rather build another one at, say, L5, because all the cylinders that are built there can be interconnected with these cables, and it will be really cheap and easy and fast to travel between those cylinders. On the other hand, if you want to go from a cylinder in the L5 neighborhood to the cylinder above Earth, it's still not going to be a big deal to do that, but it will be a longer trip than just going from cylinder to cylinder in the L5 neighborhood. All right. So all of that to answer Lord Gargomon's question. But, I've been wanting to share more of this kind of more detailed background information with you. And I actually have a write-up that I'm working on that I'm calling Future Earth History, that is almost kind of like the encyclopedia article about my setting, about the kind of the big developments that have happened between today, the current day, and when the story takes place. So right now, my plan is, once I finish all this up, to go over that again and add to that and polish that up. And, maybe that's something I can share on the show. I could read it on the show. And that's also something I could share to the patrons in a document form, so they could just sit and read it and not have to listen to me read it to them. So yeah, that's probably something I'll share to some degree. So if you're interested in that, let me know. All right. You know what? I think I'm actually going to just put a pin in this now. The next question or series of questions I was going to tackle are from Helga, our listener Helga. And just looking at my notes here, I will have even more to say about Helga's questions than I did Lord Gargomon's. And it took me, going by runtime here, it took me nearly an hour just to go over Lord Gargomon's questions. And Helga's got even more questions, and they're even more in depth as far as my answers to them. So I think this is a good place to pause. And next episode, I can resume answering these questions. And yeah, we'll just go through these until we get through them. So just to give you a preview, Helga's questions involve more society level things. How is society going to be different in the future, and specifically on these cylinders compared to present day and compared to societies on Earth? So that's some really fascinating stuff. And my answers to these continually grow. It's something I've been thinking about quite a bit lately. It's something I've been thinking about quite a bit lately. So by the time I get to record next episode, I might have even more to say about it than I do now. But just looking at my notes to answer Helga's questions are easily 3 or 4 times what I had for Lord Gargomon. So yeah, I better save that for its own episode. So yeah. And last episode, I talked more in depth about kind of the near future plans for the show. But yeah, I've got a handful of more kind of world building focus episodes planned. And then we're going to start transitioning more into character and plot stuff. So, I'm not saying that I'll never talk about world building again. I'm sure I will. I'm sure I will a lot. But the focus is going to, in the near future, shift from world building onto other things. So if there's something world building related you've been wanting to hear, now is the time to let me know, so I can get that in before we kind of move on to other things. So yeah, thank you for joining me today, and thank you for your interest and your attention. And I'll keep answering your questions in future episodes. If you would like to get a hold of me, if you have topic requests or a question or a comment or anything like that, you can email me at lexoutloudpodcast@gmail.com. You can also follow me on Twitter at LexStarWalker. And I have a voicemail you can call if you'd like to leave a voice message. That phone number is 951-465-5787. 5391. And finally, you can join our community on Discord. It's a great way to get in touch with me, to network with the other listeners, many of whom are writers as well. And also, I tend to, when I find cool news stories that are space or technology related, I tend to share those on my Twitter and or Discord. So those are great places to hang out as well if you're interested in that kind of thing. And finally, if you'd like to support the show and what I'm doing, your help is greatly appreciated. I have a Patreon. You can check that out. There's a link to that in the show notes. And I also have a support page on my site, which is linked in the show notes, where there are other ways you can help me out as well. So you can check that all out. There are some things you can do that don't actually cost you anything. So thank you for your support. I really appreciate it. You can find all that in the show notes at starwalkerstudios.com/LOL. So big thank you to Lord Gargomon for the questions today. And thank you to everyone who submitted questions. And thank you to everyone who supports the show. I really appreciate all of you. And just thank you to everyone listening. It's so great to have people listening to this super niche podcast that I'm producing. So yeah, thanks for coming along on my journey, and more to come for sure. So until next time, keep writing.